move to the next presentation with by Mr. Dr. Wataru Saeki from Obayashi Corporation. And the presentation, the topic will be about on structural system of historical log architecture.
Good evening, everyone. I'm Saeki Wataru at Obayashi Corporation. And it's a great honor to be able to speak to you today. Today, I'd like to talk about the structural system of historical log architecture in Japan. My presentation consists of 4 parts. Let me begin by introduction. Log architecture exists in areas with abundant forest resources in the world. Many have circular, oval, or rectangular cross-sectional shape. In Japan, however, there are traditional log structures with triangle similar cross-sectional shaped timber. In other words, Japanese log architecture has a very distinctive cross-section. There is no unanimous view why. Traditional architecture in Japan are mostly timber structure with post and beam construction system. Traditional log architecture in Japan are only used for storehouses to store treasures, rice, and precious documents within temples or shrine. They, azekura in Japanese, use log with triangular cross-section. The ridge lines of the stacked log are shown in the exterior, emphasizing the horizontal lines. Log architecture was used for storehouse for safety. The change in the shape of the dimension according to the climate was expected to regulate ventilation. Several hypotheses have been proposed to explain the triangular shape of this log by past researchers. For one thing, it is said that its shape helps makes it waterproof. Second, it promotes the drying of wood. And it is augured its effective sawing from lumber. I will explain more about it. This drawing shows 3 assumptions of sawing lumber to shape triangular log. As you see in the middle figure, you can see cut into 6 pieces. This method can cut out triangular pieces of wood easily. This is our objective and method of research. Our objective is to clarify the origin and change of traditional log architecture in Japan and explain the reason for the distinctive triangular cross-section of the log. We proceeded with our research by literature survey and on-site investigation. Now I talk about the result of survey. Literature surveys were done from databases of cultural property at the National Diet Library and on the internet and at other libraries. From the above literature survey together with preliminary on-site investigation, 69 log architecture were found. Thus, target of on-site investigation is 69 log architecture. 43 of them constructed before 1868, and 26 of them constructed after 1868. The 69 buildings listed below were surveyed. We conducted on-site investigation on 42 buildings. At on-site investigation, we survey the location of core and the distribution of the growth ring at the timber at each log architecture by sketching and photography. In the next slide, I will introduce some examples of Japanese log architecture. These are oldest existing examples of surveyed architecture, which constructed in around 8th century AD. The one on the left is a cultural property in Nara Prefecture, Tosho Daiji Hozo. It is known as architecture in Japan. In the middle is the Shoso in Shoso, known for its much larger size than the others. And these are examples of surveyed architecture constructed in 12th to 17th century AD. In the middle is Kongo Zanma in Kyozo, is the oldest log architecture, which use plant materials for roofing. And the left one is a first log architecture, which has gabled roof. And these are examples of constructed in 17th to 19th century AD. In the middle is Amateru Tamamikoto Jinja Hoko, the smallest known log architecture, with a floor space of only 3 square meters. These are examples constructed in 20th century AD. The one in the left is Meiji Jingu Homotsuden, which has a log structure design, but is actually built in reinforced concrete. The one in the right is Kongo Fujiroka Kyozo, which with a hexagonal plan and 2 floors. As you can see, designs are becoming more and more complex with time. Discussion. In the next few slides, I'll be showing you some new data. This map shows geographical distribution of log architecture in Japan. The left one shows the old era and the right one shows the new era. They are mostly distributed in ancient capital, Kyoto Nara area throughout the whole period. The geographical distribution of log architecture can be observed to expand in later years. As a result of our research, we found that 62% of the buildings were constructed before the 19th century. A detailed analysis reveals 3 construction systems: pure log, combination, and frame system. Pure log is a system which has no columns at all. Second one, combination system has columns, but the wall also shares the load. Frame system has columns bears the entire load. What is interesting here is that those buildings constructed before 19th century, pure log systems are surprisingly rare. Many of them are using frame methods, and there the wall is just a design materials. This graph shows how log is assembled. Type A and B are relatively high ratio, accounting for 69% of the total. And I will show example of type C and type D. You can see the differences of those 4 types. By methods of sawing log from lumber, the location of the core is different. So we classified by the location of the core and calculated the percentage of each buildings: center, edge, backside, and outside. I will now show some example of the outcome of the survey. This building is a Tosho Daiji Hozo, one of the oldest log architecture in Japan. Yellow here indicates outside, so its core location is mainly at outside. This building is a particularly special example, constructed in 17th century, with a symmetrical hexagonal cross-sectional shape. There is no other building like this one. Its core location is mainly at center. We classified by the location of the core in order of constructed year. The percentage of center core is sometimes high and sometimes lower in 7th century to 11th century, but high in 12th to 16th century. The percentage of edge core is always low. The percentage of backside core is high in 17th to 20th century. Compared to them, outside core is always more. This is a figure of all our findings, including the year of construction, how it assembly, its size of log, structural system, classification of core location, and number of layers. I'd like to summarize the main findings of this study. We surveyed all 69 buildings in Japan, 43 of which we investigated on site, and summarized the result in the table on the right. Main structural system have changed from initially combination, then pure log, frame, and reinforced concrete. As for the cross-sectional shape, the width and height were equal at first, but gradually became more vertical and smaller. Location of the core was various in ancient times. It indicates that the lumbering method was not permanent. Backside core appears in 16th century and became popular. So this is the end of my presentation. Thank you for listening. Thank you. So this is the end of my presentation. Thank you for listening. Thank you.
Thank you, Dr. Saeki. Very interesting presentation. I learned a lot. Maybe I'll ask some questions and they're technical one and they're also cultural ones. You did a comprehensive study on the section of the log construction, and then and the reason of the angle of this triangular angle, as you stated earlier, could be about waterproofing, for example. And I wonder, because there seems to be a trend in the earlier times that the angles are relatively steep, for example, in the Tosho Daiji. But for those very more recent one, 19th century, 18th century, there are almost more of a low angles. So that change, is that to do with, so I wonder why, if it is about waterproofing, then the efficiency of waterproofing there should be a science, right? So is that the change is a cultural reason, or is it or is it a waterproofing sort of scientific engineering reasons, and or is it to do with the efficiency use of the wood? I assume certain angles, so you cut hexagonal shape, then you become more efficient use of all the material. This is kind of one question that I have in my mind. The other type of questions is cultural, is and we all know this very unique log structures in Japanese traditional buildings are mainly on warehouses, and this important places that you store treasures, if I am correct. But for Todaiji or Toshodaiji, for example, the most important buildings I would assume is the temple itself. And the temples are using timber structure, but not log construction. It saves a lot of wood. But so what is the cultural reason there to be so? I'm sure there's a lot of studies on that. So the culture decided to use very specifically for the warehouse type of treasures house to be used on log. But there are other very Buddhist temples, one, but even shrine, they are not log construction, right? So Shindo shrine. So I'm curious, what is the reason? Are they because of the safety? So it's difficult to break in because they are treasure, or they seal better, so they prevent moistures and better or something. It's kind of a general question, but thank you.
Well, about the first question, I think at ancient times, it was the scientific reason why these shapes are chosen. In ancient times, Japan has abundant rainforest sources, so it is not so difficult to build such log architecture with much more wood, and it was strong enough. But after that, frame construction is popular in Japan, and it was not so popular. The log architecture was not so popular, but its special, unique shape of that type survived in history for not for scientific reason, but for cultural reason. So as you can see, at the beginning, the log architecture, the structural system was pure log or combination. But early modern ages, it became frame system. The wall is only the design material. It is all just used for its unique shape, I suggest. And yeah, is it good? Is it enough answer?
Yeah, thank you. What about this angle things that do you think is it a stylistic change, or is it a sort of experiences learning from effectiveness of waterproofing, for example? No, I'm talking about they have different.
I don't think it's effective. The log architecture is effective because the wall is only one layer. I mean, the outside and inside is so close. But so I don't think it's used for waterproofing.
I see.
Mhm.
Okay, thank you very much, Dr. Saeki, and we'll look forward for more discussion, maybe through chat box and so on. Thank you.